So here are the solutions to your Chapter 4 test. Correct what you need and prepare for your retake. We're just going to start off here with questions 1 and 2. It says match the system of linear equations with the corresponding graphs and use the graph to estimate the solution. That means that you have to actually tell me the point that they're intersecting. So what I like to do is look at the two equations. I always like to start here at the y-intercepts and try to match up each of the lines with the equation. So here in question 1, the first equation, y equals 3x minus 2, the y-intercept is negative 2. So I'm going to look at the graphs and find which one has a y-intercept of negative 2. So here, graph A, if I look at the two lines, let's see, this line doesn't intersect at negative 2, this other line doesn't intersect at negative 2. So that's leaving me with, well, B. B does have one of the lines intersecting at negative 2 right here. Let's make sure it has the same slope. So that the slope that corresponds to this y-intercept is a positive 3. That means if I rose 3 boxes and ran to the right one, then, yep, there it is. It's still on this line. So this tells me that for question 1, the graph is B. And it says estimate the solution. That means where do they intersect? Well, for graph B, they're intersecting right here. This coordinate point is 1, 1. If I wanted to check my answer, I would just plug it in. So let me go down here and say check. I'm just going to plug in this point 1, 1 to the two equations. So the first one is y equals 3x minus 2. All you're doing is replacing y with the y value and x with the x value. So I have 1 equals 3 times 1 minus 2. I get 1 equals 3 times 1 is 3 minus 2. 1 equals 1, so it works out there. And we do it with the second equation just to be absolutely positive. That's equation y equals 4x minus 3. So plugging it in, I have 1 equals 4 times 1 minus 3. This gives me 1 equals 4 times 4, or excuse me, 4 times 1 is 4 minus 3, and 1 equals 1. So it works out there. So I'm good on this first question. So the answer is B, and the point is 1, 1. This means that for question 2, the graph is A, and so A here. And the coordinate point that they intersect at is right here. This is negative 1, negative 1. Negative 1, comma, negative 1. We got to check it. Let's make sure it works out. So I'm going to check my solution with this point, negative 1, negative 1. And so the two equations, so I have negative 1 equals negative 2 times negative 1 minus 3. So I have negative 1 equals, 2 negatives when multiply makes it positive. So I have 2 times 1, which is 2, minus 3. And I do get negative 1 equals negative 1. Again, let's check the second equation just to be sure. So I'm left with negative 1 equals 3 times negative 1 plus 2. Now I have negative 1 equals positive times a negative is negative. So I have negative 3 plus 2, and negative 1 equals negative 1. So it works out there. These are your solutions here, and this red and the blue. Let's move on. Questions 3 and 4 say to solve the system by graphing. Let's just start here in this first equation. I will graph the first one in red, and I'll graph the second one in blue. So I'm just going to graph the two equations like I would and what I learned how to do in Chapter 2. That means you start at this y-intercept. The y-intercept is the number without the variable, so this is plus 1. So I'm going to start by plotting that point. My slope is the next. It's negative 2. That means from my y-intercept, I'm going to fall 2 boxes and run to the right 1 box. And just to be clear, I'll do a point that's above my y-intercept. To do that, I reverse my slope. Instead of falling, I rise. Instead of running right, I run left. And then you'll take your ruler and you'll just connect your points. Okay, second equation. We have y equals 2x minus 3. Y-intercept is negative 3. I'm going to plot that first. Slope is positive 2. That means I rise 2 boxes. I run 1. I would like to get another point in here. I can't really go below without having to make my own graph, so I'll just add another point. So from where I left off from this last blue point, I'm going to rise 2 boxes, run 1, and then I'm going to use my lovely ruler and I will connect my points. This right here is only half your problem. The final part is to see where do they actually intersect. And they intersect right here. What is that coordinate point? Because that coordinate point is your answer. It is 1, -1. And you can always plug that in to check it, but trust me, I'm your check right now. It does work out. Okay, let's jump over here to 4. I'll do the same thing. The top equation will be in red, the bottom will be in blue. Always start your y-intercept for the top equation. The y-intercept is -3, so I'm going to plot that first. Slope is a +6, so let me just rise 6 boxes and run to the right 1. So I have 1, 2, 3, 4, 5, 6. Run to the right 1. Now I can't draw more than this without having to extend my graph. So that's a little frustrating, but that's okay. I'll just connect what I have. It's going to be a pretty steep line here. Oop, froze on me. Let's extend that. No. There we go. Okay, second equation, the y-intercept is -1. We'll plot that first. Slope is 4. So that means I rise 4 boxes, run to the right 1. So I have 1, 2, 3, 4. Oop, run to the right here. These 2 points are actually, I think I shifted my graph here just a bit. Yeah. My red dots aren't on the point. Oops. So let me just redraw my blue one because I had shifted my graph on my board here and it just didn't match up. So let me just start again here. So y-intercept is -1, rising 4, 1, 2, 3, 4, run to the right 1. There we go. And let me connect my points to my lovely, lovely ruler here. There we go. Again, you're not done until you tell me what's that point of intersection, and it intersects right here. Doesn't look like it was my line, but that's where the 2 points intersect. So this answer here is at the point 1, 3. And you can always plug it in to check, but I'm your check, and I'm telling you it's working. Okay, let's move on. 5, 6, and 7, they solve this with substitution. Substitution means we're taking one equation, plugging it into the other. This is going to take a lot of space here, so let me just start here on 5. Substitution, when both of the equations are solved for the same variable, what that means is you can just take one of them. It doesn't matter which one. I like to work top to bottom. So here I have y equals x plus 2. You take what this y equals, so x plus 2, and you plug it into the second equation for that variable. You substitute it in. So in 5, I end up getting a problem. X plus 2 equals 3x minus 4. And this becomes a chapter 1 problem, variables on both sides. So I'm going to move my variables. I'm going to subtract x first. This gives me 2 equals 3x minus, there's a secret 1 right here, minus 1x is 2x. Didn't do anything with minus 4, so I'll bring that down. Getting my variables by itself, I have to move this constant, or this normal number. I'm going to undo subtraction with addition. So let's add 4 to both sides. This leaves 2x on the right. 2 plus 4 is 6. Getting x by itself, I'm undoing a secret operation of multiplication with division. So I'm going to divide by 2. And this tells me x equals 3. Well, I'm not done, and I'm not done because I need to find my y coordinate. So I'm going to take this value I just came up with, and it doesn't matter which one you plug it into. I say plug it into the one that looks the easiest. I would say this top equation looks the easiest, so let me do a little separation here. I'm going to plug my x equals 3 into this equation, so let me do a little squiggle. I'm going to have y equals, and instead of x, I'll write that value of 3. So I have 3 plus 2, and 3 plus 2 is 5. So this tells me that my solution is a coordinate point 3, 5. Trust me when I tell you it does check out. You can plug it in on your own to prove that to yourself. Let's move on to question 6. Question 6 here, one equation is already solved for a variable and the other is not. So what this tells me is I can take what y equals, like I did in this last problem, so this 3x plus 4, and I'm going to substitute it into the second equation. But I'm going to have to put it in parentheses. I'm going to treat it kind of like a distributive property. So what I end up getting is x plus, and in parentheses, 3, let me do that in a different color, 3x plus 4 equals 8. Well, there's a secret 1 out here. Let me do it black. There's a secret 1 right here in this parentheses, so you can think of it like I'm distributing a positive 1 into the parentheses. There we go. And that allows me to kind of get rid of my parentheses, because it's 1 times 3x, which is just a 3x, 1 times 4, which is just 4. So I'm left with x plus 3x plus 4 equals 8. I need to combine my like terms, so those are my variables. X plus 3x, that's 4x plus 4 equals 8, the two-step equation. Move our constants by undoing addition and subtraction, so opposite of addition, subtraction, so subtract 4 from both sides. This gives me 4x equals 8 minus 4 is 4. Getting my x by itself, I'm undoing the secret operation of multiplication with division, so I'm going to divide by 4 on both sides. This tells me I have x equals 1. Now I'm not done. Now I have to find my y coordinate, so I'm going to take what this x value, I'm going to go back up to the beginning, and I'm going to plug it in to this top equation. The reason I'm choosing to plug into the top equation is because it's already solved for y. That's what I want. So that's actually the easier equation. Again, let me do a little separation bar here. A little squiggle wiggle. So if I plug this x equals 1 into the top equation, I have y equals 3 times the x value, 1 plus 4. This gives me y equals 3 times 1 is 3 plus 4. So y equals 7. So our actual final answer, squiggle wiggle, is a coordinate point 1, 7. Again, you can check your work by plugging this in to prove that to yourself. Okay, number 7. Number 7 was commonly missed, and it's made because of mistakes made when you substitute the expression into the other equation. So in this case, we do still have one equation that is solved for a variable. That's this bottom equation. It's a little bit different than this question 6, just because they're in different spots. It doesn't mean the process changes. So I already have one equation solved. That's exactly what I want. So I'm going to take this y, what it equals, which is 2x plus 7, and I'm going to plug it in to this variable. Now you have to remember that 3 and this y are connected with multiplication. So when I substitute it in, it becomes a distributive property. So let me kind of start doing that here. I don't do anything with negative 2x. I just have bring that down. I have negative 2x plus 3 times, and now in parentheses, what is y? Well, y is this expression, 2x plus 7, and that's all equal to 9. Distributive property, 3 has to distribute in. Multiply it into this 2x, multiply it into 7. So this leaves negative 2x plus 3 times 2x, that's 6x, plus 3 times 7 is 21, equals 9. Combine like terms, those are my variables. Negative 2x plus 6x is 4x, plus 21 equals 9. Getting my variable here by itself, I'm going to undo this addition with subtraction. So I'm going to subtract 21 on both sides. This gives me 4x equals 9 minus 21. That's negative 12. To get my variable by itself, I'm going to undo the secret operation of multiplication with division. So I'm going to divide both sides by 4. This tells me I have x equals a negative divided by a positive is a negative. 12 divided by 4 is 3. Now, I'm not done until I find this y value. So I'm going to take what I just came up with, x is negative 3. I'm going to plug it into the easier equation, which is actually the bottom one, because I want y, and y is already alone. So I'm going to go over here, do a little wiggle. I'm going to plug the x value of negative 3 into this equation. So I have y equals 2 times negative 3 plus 7. So I have y equals a positive times a negative is a negative. 2 times 3 is 6 plus 7. This tells me y equals 1. And our coordinate point, remember that's how you write your answer, is negative 3, comma 1. Okay, so that is your final answer. You can again plug it in to check your work, but you can do that on your own time. Let's move to the tough problems, the word problems. So here we have question 8, and this says there are 27 red or blue marbles in the bag. The number of red marbles is 5 less than 3 times the number of blue marbles. How many red marbles are in the bag? And how many blue marbles are in the bag? Well, each sentence tells me a piece of information. The first one says there are 27 red or blue marbles. Well, I don't know how many red, I don't know how many blue, so these actually represent my variables. You guys know I like x and y, but I saw a lot of you use r and b, so I'll just do that with you. What this means is that the red marbles combined with the blue marbles gives me 27. Don't get too caught up with this or. It's just, I don't know how many red, and I don't really know how many blue, but somehow this combination gets me 27. So one of my equations is actually r, so red marbles plus blue marbles, is supposed to give me a total of 27. That's your first equation. That's from the very first sentence. The second equation comes from the second sentence. It says the number of red variables, so this, I don't know what this is, my red variable is represented by r, is in math represents equals. So r equals, and this is 5, that's a nice number, less than 3 times the number of blue. Well, in our equations, think about y equals mx plus b. We always talk about a variable times, our number times a variable, then we do addition and subtraction to the right of it. That's how you want to be writing your equations. So I'm going to have r equals, multiplication goes first, 3 times, that's multiplication, the number of blue. I don't know blue. Blue is represented with the letter b. So I have 3 times b, and at 5 less than that, that means take away 5. This is your system of equations. And this is already in the form of substitution, because one equation is already solved. That's my r. So you want to take what r equals, 3b minus 5, and plug it into the top. So now I have 3 times b minus 5 in parentheses plus, I don't know, b equals 27. Remember, there's a secret 1 in front of these parentheses, so it's really a distributive property of a positive 1. And if I multiply a positive 1 into my parentheses, I just get 3b minus 5. And I can combine everything else. Plus b equals 27. Combine my like terms. Those are my variables. So I have a 3b and I have a positive 1b. That gives me a total of 4b minus 5 equals 27. It's a one-step equation now from chapter 1. So undo addition and subtraction. I'll undo subtraction with addition. So I'm going to add 5 to both sides. And this now gives me 4b equals 27 plus 5. That's 32. Getting b by itself, I'm going to undo a secret operation of multiplication with division. So let's divide by 4 here on both sides. This tells me b equals, well, 32 divided by 4 is 8. So I know I have 8 blue marbles. I am not done until I figure out red. So just like we were doing on the last 3 problems, take this value of 8, go back to the beginning and plug it into the easier looking equation. Well, I already have my blue, so which equation gets me my red? Well, that's the bottom one. R is already by itself. So let's do a little squiggle wiggle, and we'll get R, or red, equals 3 times, let's see, what is our blue value? Our blue is 8. So I have 3 times 8 minus 5. Going forward from here, 3 times 8, that is 24, minus 5. This tells me my red is 19. So let me just kind of put this together nice in some words here. So red marbles equals 19, and the blue marbles equals 8. I saw a lot of you get these numbers and then you mixed up your variables. Be very careful. When you name a variable, you have to be consistent in your final answer. But that, there you go, is question 8. Okay, so let's finish up the front page with question 9. This one caused so many issues, and it's because of this ratio right here. But let's go to the problem. It says a fruit vendor sells 60 pieces of fruit that are either apples or oranges. Again, it's the same idea as this last one. Don't get caught up on this or. It's some number of apples and some number of oranges. We just don't know which one, how many of each, but I do know that combined there's 60 pieces. And then it says the ratio of apples to oranges is 3 to 2. How many apples did the vendor sell and how many oranges did the vendor sell? Well, that right there, that tells me my variables, the apples and the oranges. I don't know which one's which. I gave you guys, I want you all to be consistent, so I told you to let X be your oranges, and let Y be your apples. Yeah, so to go through our problem, this tells me, the first sentence gives me my first equation. If I have 60 pieces of fruit, some of them are X's, some of them are Y's, or some oranges, some apples. So I have the equation X plus Y equals 60. That is your first equation, and it comes from the very first sentence. The second equation comes from this ratio. Well, the ratio of apples is Y, is, apples to oranges, yeah,